We heard several times this morning about the importance of integration and collaboration, and hopefully this presentation will give an example of a project that is kind of taking that message to heart. So this first slide shows the study area for our project. It's a regional water inventory. So it's integrated in the sense that it's looking at the potential for surface waters, superficial sediment, and shallow bedrock hosted aquifers, so that would be non-saline, and then also deeper saline aquifers. And it's hits the collaboration angle in that it's supported by 8 industry partners, and also supported by PTAC and CAP through the AUPRF funding. So the study area encompasses the fairways of the Duvernay and the Montney plays in western Alberta, as well as several other unconventional gas plays that are located within that area. The project goals are to provide a comprehensive assessment of the potential water sources to support unconventional play development in western Alberta, looking at both water sourcing options and also disposal for deep well disposal, and to support all stages of exploration and development. And with such a large study area, we take a kind of a regional approach to looking at the options, but also provide sufficient detail with the project outputs to support local project scale applications for the partners. And all of the data and the analysis results are all compiled and provided in a GIS-based framework. And we feel that the project will be very useful to industry regulators and also public stakeholders who are interested in water sourcing and disposal options. So the project team, Integrated Water Resources, is made up of 3 companies. Someone from each of these companies is here today. So Strategic West Energy provides the project management and oversight. Foundry Spatial is the lead on the surface water, the spatial databases and the integration. And Petrel Robertson Consulting is the lead on the deep saline and shallow non-saline aquifer component. And our team came together based on previous projects that we worked on, most notably the Montney Water Project in BC, which was supported by Geoscience BC, and also the Horn River Basin projects. So we're just in the transition point between year 1 and year 2 of this project. The first year, it took us a while to get things underway, bringing all the companies together that are participating. We looked at, for the surface water and shallow aquifer components, we looked at bringing together all the vast amount of information that's available from existing studies, research reports, and also the huge amount of data that's out there. Bringing that all together and then doing regional analysis on basically the existing level of knowledge. And for the deep saline aquifers, there was regional mapping and characterization of high priority targets, which Brad will talk about in a little more detail. And also the development of a spatial project framework and query tools. And in year 2, in general, we'll move into more detailed work on the surface water that'll involve hydrologic modeling to quantify the water source across the region. And for the subsurface, there'll be additional detailed characterization of the aquifers, quantitative modeling to understand the producibility. And we're also increasing the level of engagement with the regulators to ensure that the results and the tools meet the needs for the companies in their interactions with regulators going forward. So on the surface water component, there's a huge amount of existing information in the region. 183 hydrometric stations with high quality data available on the existing surface water resource. That's out of over 300 stations that actually exist within the project area. So on that item, we put together a toolkit looking at relevant hydrologic characteristics for those water bodies. Things like the unit runoff, flow duration, flood frequency, and several other items of interest. And when you think about surface water, it really makes sense to think about all the components of the water cycle that influence the availability of water. Climate is critical in terms of precipitation being the only real input into the water cycle. The hydrology, regional hydrology that's been mapped previously by government agencies primarily. And surficial geology, which influences the interaction between the surface water and groundwater resources. And within this analysis framework, we've also incorporated the groundwater, the non-saline groundwater, and also the deep saline aquifer resource across the region. So moving right into the results and integration component. In the watershed context, you can look at those thematic type data representing the different components of the water cycle and also the groundwater resources across the region. So this lets you compare and identify the options based on the specific area that you're interested in. On the shallow groundwater component, there's a huge amount of previous work that's been done both by the provincial government and also the federal government through the Prairie Farm Rehabilitation Administration. There's over 20 separate studies done from the late 1960s until about 5 years ago, looking at the primarily shallow hydrogeology and potential for water availability in the region. So that's one of the big components of data that we brought together in the first year, and that will support the more detailed work in years to come. And with that, I'll hand it over to Brad.
Thanks, Ben. I'd like to just speak to in a little more detail about some of the shallow aquifer work, both the superficial sediments and the shallow bedrock, and the deep saline aquifer characterization. So we kind of switched over on this map here. It's a handy spot where, say, under Ben's direction, a lot of these shallow groundwater reports and data were collected, as he's mentioned. We're hoping that we're able to, in year 2, do a deeper level of analysis geologically on some of this information to characterize as to what the actual shallow groundwater resources and availability might be to companies operating in the area. And as an example, what one might hope to identify are major glacial paleo valley systems that have gravel or sand fill that will be high quality aquifers. We know that particularly in oil sands operations right now, that some of these serve as great water sources for particular projects, and it may be the case in West Central Alberta as well. The other aspect of shallow aquifers, particularly the most important potential shallow aquifers, the Paskapoo Formation, which you'll recognize as being the sandstones that crop out around the Calgary area. The blue shows the extensive area of West Central Alberta within the study where the Paskapoo exists. It's a very enticing reservoir because it offers aquifer potential in many areas where our deep saline mapping work has shown that saline aquifers may not be of sufficient quality. For example, as we just heard in the Horn River Basin, the Debold aquifer is a very high quality reservoir in some areas and not in others. Similarly, in this much larger West Central Alberta area, we have areas well serviced by deep saline aquifers, others where the deep saline is not going to work. So we're going to have a major bit of detailed mapping and characterization focused on the Paskapoo in year 2 of the study. Now, Paskapoo carries non-saline waters, so there's going to be regulatory aspects as to whether or not companies can systematically access and use that water, and we're hoping that the results of our study can be used by the regulators and by industry to help make the decisions as to where the Paskapoo, for example, can be a viable water source and will not cause conflicts with other stakeholders. So that's going to be an interesting part of the second year of the project. We also face, as we have in the other studies we've done of this integrated type, the issues of data. Many of the deep saline aquifers, we can use petroleum wellbore data to characterize the reservoirs in terms of their quality, their fluids, their pressures, and so on. When we're dealing with something shallow like the Paskapoo, we've got to use everything we can lay our hands on. There's not very many petroleum boreholes that have good Paskapoo data. We have to use what we've got. We also have to use water well data from domestic water wells, agricultural wells, outcrop data, basically anything we can lay our hands on. And we certainly are relying upon some of the really good work that's been done in the past by Alberta Geological Survey and other government agencies. Just a schematic cross-section, one of these three, they're showing a little inset map at the bottom of some of the stratigraphic units in west central Alberta. And what I want to point out with this here, so if I can find the arrow, there we go. These red areas kind of over to the west represent aquifers or potential aquifers of mostly of Cretaceous age. Where they're red, they are in the deep basin regime. Hydrocarbon saturated, so oil and gas, they will not flow water and they won't take water if you try to inject it. The brown layers here are dominated by shales, and they're not useful either. We have to focus on the blue zones. These are the regional aquifers where we see aquifer sufficient quality, and we also have water in the reservoir system, so that they are the candidates for mapping and characterization. So you can see as we look through the entire section, ranging from the Devonian down deep here up to the shallowest Cretaceous reservoirs, we've got a variety of zones that we can pursue. And indeed, in year one of the study, we selected 6 of the highest potential regional deep saline aquifers for characterization on a regional basis. And I'm just going to show you a couple of slides as an example of the analysis of one of those units. Say, with the year one study that's just been completed and report delivered, or draft report delivered to the participants, they will see detailed regional mapping on all 6 of these horizons, and we'll be integrating that work and using it to drive year 2 work. So here's our example of one of the deep saline aquifers. It's called the Cadotte member. It's of Cretaceous age. We can map it in the northern part of this study area. So up in here in sort of the northeastern corner of the Montney and Duvernay fairways, particularly the Montney fairway. And what we've got here, key features here, there's a depositional edge right along the margin there, so the Cadotte occurs only to the north. In the southwestern part here, where the arrow is, the Cadotte is in that deep basin regime that was colored red on the regional section, so it's gas saturated and therefore it's not a viable aquifer target. So this particular deep saline aquifer unit is a viable aquifer source and disposal zone, potentially in the blue colored areas. We've taken existing, I wish I could quit doing that, existing water well data. Some of these big, sorry, there we go. Some of these big blue dots up in here are water source and disposal wells. So we've got quite a bit of information on this. We've been able to subdivide the Cadotte area into a high prospectivity aquifer in the darker blue and a lower prospectivity aquifer in the lighter blue. So really, when you come right down to it, in terms of providing the appropriate reservoir quality, water source rates, and so on that companies really need to operate, the prospectivity of the Cadotte as deep saline aquifer is probably limited to this dark blue area here. We've done similar characterization work, and there's a lot of detail that goes behind this, incorporated on our reports, that we've done the same thing with the other 5 units throughout the area, and we found that this northern part of the Montney Duvernay exploration fairway is actually reasonably well serviced with deep saline aquifers, but that many of the more southerly areas have much less potential. Lots of the, down through here, lots of this area all of the Cretaceous sand targets, for example, are in the deep basin regime. This is where the Paskapoo is, and this is why it's important for us to look at the non-saline as well in order to get the complete water picture in the area. And just threw in this this chart as well. In looking at the hydrogeology, for any of those of you that are into this sort of thing, we plot the reservoir pressures versus the depths and so on. And for the case of the Cadotte here, the single blue line diagonally through the area tells us that we've got a single continuous water system that is of high quality and good continuity, which reassures us that this is indeed a good quality target. The little red spots and so on there are associated with individual gas pools, and their areas basically we've got to avoid. So unlike what we've been doing in our company for most of our history, we're trying to avoid those gassy spots and drill the wet places, which is a little bit different, but that's the nature of the game these days. And just to point out the couple of points on the right then, the fluid characterization, so understanding the salinities and the chemistries of the waters. We have not found, for example, in any of the aquifers examined in west central Alberta that H2S is an issue, but variable salinities certainly are. And many of the deeper aquifers that look like they may have potential interest to industry operators indeed may have some H2S, and they certainly have very high salinities on the order of 100,000 TDS milligrams per liter, compared to something like 25 or 30,000 in the DeBolt in the Horn River Basin, pulling that from memory, so I don't know if it's right or not, but it's something like that. So much more saline waters. The Cadotte itself is more friendly. It's sweet and on the order of perhaps 25,000. An aspect of our project that we're working on right now is project outreach. We're doing a lot of technical work. Ben has shown you the immense amount of data that's been collected onto the website, including all of this mapping that we've done in the deep saline and the shallow aquifers. We need to communicate that out to industry and the stakeholders. Right at this moment in formulating our year 2 plans, we are working with the industry participants, with PTAC and with CAP, to develop a communication strategy so that these technical results are available not only to the operators but to everyone, including watershed planning, advisory councils, and other interested stakeholders, for their use in a fashion that is useful to them. As you can appreciate, many of the maps and products that we produce are relatively esoteric if you're not a professional in that field, so there's going to need to be some communications work done there. So just to summarize then, in terms of the entire project, we're integrating surface waters, shallow aquifers, and deep waters, assessing them and providing an independent regional overview of water availability to support unconventional exploration and development. We are enabling productive collaboration between industry, government, and communities. We're giving government agencies direction in their land use framework regional planning and the development of new regulatory regimes dealing with unconventional resource development. And it's an important platform to communicate our science-based water information to all the different target audiences. So we're hopeful that by the time next year rolls around, that we'll have a product that is available for everyone to see in an understandable form that provides a really good, complete regional framework to water availability, disposal zone availability for unconventional resource development. However, when that's accomplished, it still will only be a regional framework. Every company will still need to build from the work that's been done here to understand what the options are in their particular project area and to gain the appropriate regulatory and stakeholder approvals. Thanks very much.